Hey guys, Mrs. Hydrick here with your Topography Objective 1 video. Make sure you have set up your Wix. Pause the video now if you haven't done so. Our objective today is to recognize how landforms such as deltas, canyons, and sand dunes are the result of changes to Earth's surface by wind, water, and ice. We have 5 essential questions we're going to answer. I've marked out question number 6 because it will be answered during your Topography Objective 2 video. Let's start by defining a topographic map, which is a map describing the physical features of a geographical area, especially changes in elevation. So really, a topographic map is a two-dimensional flat map representing a three-dimensional landscape feature. So down here we see that we have a side view of 2 hills, Able Hill and Baker Hill. Now at the bottom, these 2 hills are one, but then as we go up to, I don't know, somewhere around 25 meters, they kind of separate into 2 hilltops. And so up here, we have the same landscape feature as a two-dimensional flat topographic map. And we see that at the beginning, they kind of share these lines, and then eventually they become completely separate as both of our hilltops kind of separate. So we have Able Hill and we have Baker Hill. We can see that the lines change by 10 meters. That's our interval. That's how much the elevation is changing as you move from one line to the next. With Able Hill being right at about 42 or 43 meters high. So the last line we see is 40. But Baker Hill goes all the way up to 50, so the last line we see is actually 50. Notice, though, that Able Hill is higher than 40 meters. It's just not high enough to have that 50-meter circle in there. We're going to talk a lot more about this as we go along. I just wanted to kind of give you a quick introduction of a topographic map. So let's define a satellite image, which is photographic representation of an object taken using a satellite. There is a lot of satellites orbiting the Earth. Some of these satellites take pictures using infrared filters. Some use visible light to take just regular photographs. And these images are used by a lot of different people. Cartographers, which are map makers. People who make topographic maps use these satellites to help them see changes in elevation. Military intelligence also will use these satellite images to help them track different groups of people. Weather forecasters will use these images to help them track weather systems like hurricanes and weather fronts. And climatologists will also use satellite images to help them track the changing of our glaciers as a result of global warming. Here is a satellite image of the Mississippi River Delta. And you can see the Mississippi River. It's kind of this brown line that's sort of snaking its way through Louisiana, and it dumps out into the Gulf of Mexico. And you can see all of the sediment that's being deposited into the Gulf from the Mississippi. Now, a delta is a wetland area that forms as a river empties their water along with their sediment into another body of water. And that body of water can be an ocean, like here, the Gulf of Mexico, or it can be another lake or even another river. So these deltas are a result of deposition. This is a satellite image of the Grand Canyon. A canyon is a deep ravine between 2 pairs of cliffs that are most often carved by the erosive activity of a river. This process takes a long time, hundreds if not thousands of years, for the water to erode the landscape enough to create a canyon. Canyons can also form as a result of glacier movements. As glaciers slowly move across a landscape, they can scratch out very deep gorges, and then when those glaciers melt, maybe as a result of climate change, then the leftover ravine will be there. And so we can use satellite images to help us study the changing landscape of gorges and canyons like the Grand Canyon as the Colorado River continues to erode the landscape. This is a satellite image of some sand dunes. Now, when we think about sand dunes, we think about the beach, and there are lots of sand dunes in warm areas, but you might not be aware that there are sand dunes in cold polar regions as well. This is a satellite image of the Great Kobuk sand dunes, which can be found in Alaska. Now, a sand dune is a mount or hill or ridge of sand that forms over many years when the wind blows sand and that sand gets trapped by a stationary object, like a change in the elevation of the ground or something like beach grass. Now, what's neat about these polar sand dunes is that the wind changes these dunes much slower than the wind changes the sand dunes in a warmer climate. Warmer climate sand dunes can change very rapidly over a very short amount of time, whereas a polar sand dune takes a lot more time. And they actually will use this sand dune area in Alaska to help them test their Mars rovers, because scientists believe that the landscape here is very similar to the surface of Mars. So we're going to jump to essential question 4 and 5 and define a contour line and a contour interval. So a contour line is a line on a topographic map that connects points of equal elevation. And our contour interval is the difference in elevation from one contour line to the next. So if we look over here, we have this line that has an elevation mark of 100. So all of the points along this line have an elevation of 100 meters because the elevation is measured in meters. Now this location here has an elevation just above 100 meters. Now the next line isn't numbered, and neither is the next. The next line that's numbered is all the way over here at 200. So all of these points along this 200 line, they all have an elevation of 200 meters. So what then is the elevation of this X right here? I don't really know what this X elevation is, but I can figure it out by determining the contour interval. To get from the 100 meter contour line to the 200 meter contour line, I have to make 1, 2, 3, 4, 5 jumps. So there's a 100 meter difference. 5 jumps means that I had to change my elevation by 20 meters each time. So this line would have an elevation of 120 meters. This line would have an elevation of 140 meters. This line would have an elevation of 160 meters. This line has an elevation of 180 meters. And this line then has an elevation of 200 meters. So the contour interval, or the difference in elevation from one contour line to the next, is 20 meters. So this X right here, the one in the middle, has an elevation higher than 140 meters, but lower than higher than 160 meters, but lower than 180 meters. And we'll have lots of time in class to practice identifying the contour interval and trying to figure out the elevation of different locations on a topographic map. You also need to be able to recognize steep slopes from shallow slopes, and this is essential question number 3, topographic map symbols. So looking at this side view of this hill, on the left side of the hilltop, the slope to the hilltop is much more gradual than the slope on the right side of the hilltop, which is much more steep. So when you look at a topographic map, the farther spaced apart the contour lines are, the more gentle the slope, whereas the closer the contour lines are, the steeper the slope. So make sure you can look at a contour map or a topographic map and identify where the slope is steep and where the slope is more shallow or gentle, based on the spacing of the contour lines. You also will need to be able to identify hills. Hills are indicated by circles, with the top of the hill being the innermost circle. Now notice the innermost circle here is very small, whereas the innermost circle here is very big. What that shows you is that on this map, where the inside circle is very small, the peak of that hill is very sharp or pointy. Whereas the peak of this hill over here, because the inner circle is much larger, the peak of that hill is a lot more flat. Now a valley is indicated by a V shape in the contour lines. So here on this map we have all these contour lines, and notice how they kind of make a V shape right through here. Now with these V's, the point of the V will point uphill. So if you look, all the V's are pointing this way. So up here, this is the top of the hill somewhere up here, because the V is going to point uphill. So all the V's are pointing up the hill. Now rivers, which generally travel through valleys, will flow downhill, which means the river is going to flow through the widest part of the V. So if I was to try and identify the direction that this river here is flowing, I would say that this river is flowing to the north, because that is the direction that the V is opening up. So the river is flowing north. Now this happens to be a permanent river, a river that is flowing year-round, and I know that because it's a solid line. If this was a dotted line, then that would indicate a seasonal river, which only flows after either a rain shower, or it might flow in the spring as the snow is melting and the water is flowing downhill. You also need to be able to identify a depression, and a depression is basically a circle that has a hash mark. Those hash marks represent a decrease in elevation instead of an increase in elevation. So let's practice a little bit figuring out the contour interval of this little map here. This line here is 200. This line here is 300. And so I have 1, 2, 3, 4, 5 jumps. So it's a 100-meter difference, 5 jumps to get there. So the contour interval is 20 meters. So the elevation is changing by 20 meters every time I go to the next contour line. Now I did not include this contour line in my contour interval because of the hash marks. So this is a depression. So what is the elevation of the depression? Well, if I go from here 200 meters to 220 meters to 240 meters, when I go to this one, the elevation is decreasing by 20 meters. So the overall elevation of my depression is 220 meters. All right, so let's practice real quick answering a few questions using this topographic map. We'll be doing a lot of practice in class, but you should be able to answer these questions here from the information I've given you in this video. So let's first start by answering the first question: what is the contour interval? Well, this is an easy map to figure out because each line has an elevation indicated. And so you can see that the elevation is changing by 10 meters every time you see a contour line. So the next question: what is a possible elevation for Hilltop X? Well, here is Hilltop X right here. We have a 290 meter contour line, but we do not have a 300 meter contour line, which means the elevation, a possible elevation, is anywhere from 290 to 299 meters. Now, it can't be 300 meters. If it was 300 meters, you would see a 300 meter contour line. Since we don't, the elevation of Hilltop X can be anywhere from 290 to 299. What direction is the river flowing? Well, here we see a river. It's a seasonal river, by the way. Oh, I've already answered that question for you. Haha. You can see that the river is flowing through the wide part of the V, or the valley. So it starts, this one is traveling southwest, this one's traveling more south, and then they meet up and they continue traveling to the southwest. What is the difference in elevation from point X to point Y? Well, point X is about 290. Point Y is about 240 for a difference of 50 meters. And then I already gave you the answer to this one. What type of river is shown? Well, it is a seasonal river because the line is a dotted line. Don't forget your support item, which is to draw a topographic map of the image shown here. We have 3 hilltops of different elevation. Your interval should be 100 meters, and the highest peak should be 1,100 meters, and the base of the mountains are at sea level, which is 0 meters. So see what you can do with that support item, and don't worry, we're going to get lots of in-class practice interpreting topographic maps. I'm out.